Determine the equation of a line that is 3 times square root of 2 units away from the origin, and it forms a 75-degree angle with the positive x-axis. Okay, let us begin. So here, let's try to understand the problem graphically first. So here we have the xy coordinate plane and the straight line L. Now the straight line L intersects the x-axis at A. So this is intersecting in a positive direction of x, and then it intersects the y-axis in the positive direction at B. Now OC is the perpendicular on the line L, or we can say that OC is the perpendicular distance of the line from the origin. We will denote OC with P. Now the perpendicular line is going to make an angle of 75 degrees with the positive direction of x-axis. Our goal will be to determine the equation of this line. So here, let's write down whatever is given to us. So here it is given that the perpendicular distance of the straight line from the origin, that's 3 times square root of 2 units, and alpha, which is the angle that the perpendicular line OC makes with the positive direction of x-axis, that's 75 degree. So our goal will be to determine the equation of the straight line. So using the normal form of a straight line, the normal form is given by the equation x times cosine of the angle alpha added to y times sine of the angle alpha, that is going to be equals to the perpendicular distance P. So let's substitute our value. So we have x times cosine of angle 75 degrees added to y times sine of the angle 75 degrees, and that is going to be equals to the perpendicular distance 3 times square root of 2. Let's label this as number 1. Our next task will be to obtain the value cosine 75 degree and sine 75 degree. Let's begin by first computing cosine of 75 degree. So what we can do, we can break down 75 degree as the sum of 45 degrees plus 30 degrees. So this becomes the cosine of a compound angle. Or we can break it down to get cosine of 45 degrees times cosine of 30 degrees minus sine 45 degrees multiplied to sine 30 degrees. So what is cosine of 45 degree? That's 1 over square root of 2 multiplied to cosine 30 degree, that's square root of 3 over 2 minus sine 45 degree, that's 1 over square root of 2 multiplied to sine 30 degrees, so that's going to be 1/2. So let's combine it, and cosine of 75 degree comes out to be square root of 3 minus 1 divided by 2 times square root of 2. This is going to be the value of cosine of 75 degrees. Next, we will find out the value of sine 75 degrees. So sine 75 degree, that is going to be equals to sine of 45 degrees added to 30 degrees. So we now expand sine 45 plus 30, we get sine 45 degree multiplied to cosine of 30 degrees added to cosine of 45 degrees multiplied to sine 30 degrees. Now when we substitute the values of sine 45, cos 30, cos 45 and sine 30, we're going to get square root of 3 added to 1 divided by 2 times square root of 2. So we now have the value of cosine 75 as well as sine 75 degrees. So let's substitute these values back in equation number 1. So now equation number 1 follows that we have x times cosine of 75 degrees. So that's square root of 3 minus 1 divided by 2 times square root of 2 added to y times sine 75 degrees. So we obtained it as square root of 3 added to 1 divided by 2 times square root of 2. This is going to be equals to the perpendicular distance, which is 3 times square root of 2. We have 3 times square root of 2. Let's further simplify. We're going to multiply throughout with the denominator 2 times square root of 2. So we now have x multiplied to square root of 3 minus 1 added to y times square root of 3 plus 1. This is going to be equals to, so 3 times square root of 2 multiplied to 2 times square root of 2. So that's going to be equals to 12. Fine. Further simplifying, we get, let's keep it as it is. So this is going to be the equation of the circle. Thus, we get square root of 3 minus 1 times x added to square root of 3 plus 1 times y equals to 12. This is going to be the required equation of the straight line.